Hello, it's Duncan. I've been reviewing Uberto Barbini's book, From Objects to Functions. In it, Uberto shows how to use event sourcing to treat updating data in a functional way. As luck would have it, Team Gilded Rose has started work on stock management, so this looks like a thing we should investigate. Equally unbelievably, it turns out you don't need Kafka to implement the technique, so in this episode we'll write some simple code to try to learn the basics. We've had some good news. You may remember that we had a task to amalgamate prices from different services, this one here. Well, it turns out the reason that ValueAlf, the first pricing supplier we integrated, was at first buggy and then slow, is they are in fact now amalgamating results themselves. Our customer Alison, the owner of Gilded Rose, is happy with the results we're getting. So we can not do this amalgamation story and instead move on to her next highest priority, which is adding and removing items from the stock list. See, the story is here, and it says, we're currently reflecting and updating the quality in an Excel TSV tab separated file that I'm editing by hand. I'd like to find a way to add and remove items from the stock list through the software. So let's remind ourselves what we're doing at the moment. We are taking this stock file here and we're parsing it, and this contains information about items, an ID, a name, what their sell by date is, and what their current quality is. And when our software reads this file, it looks at its last modified date and decides whether another day has passed since it last read it, and if it has, it updates these qualities according to the complicated rules that apply to magical items. You can see that code here in stock. You can see that we load the items from the file, and if that succeeds, we then work out how out of date the file is. We update the items according to a complicated strategy that's reflected by this item update function. And then if it is out of date, we save it back to the stock file. And because of concurrency, we have to worry about multiple requests happening at the same time. It's pretty unlikely to happen, but we're a bit scared about it. And so we are saving versioned files here and creating temporary files and renaming them because renaming is atomic in the file system and so on. So we're jumping through a lot of hoops to be safe here to avoid corrupting this file. We save backup versions. We leave these temp files lying around, but that's the only history we really have. Now, event sourcing says we'll work from the history. We'll remember everything that happened to our data as events, and then we'll recreate the current state by working through those events and applying the consequences. Now, don't tell Alison, but we'd like to put event sourcing on our CV, so we're going to experiment a bit and see whether it would be suitable for implementing this story. Right then, I've added StockEvents tests in our persistence package, and my plan is really just to experiment in here, get a feel for the sorts of issues that we might have. And I think I'm going to sketch out the type rather than writing tests first. So I believe we're going to be dealing with stock events. So let's make that a sealed class. And the two types of stock event we know we have at the moment are items added and items removed. So we can add in a data class for StockAdded, which is a stock event. Now, if we're going to use our StockAdded event to create our items, then the event is going to have to carry all the data we need for an item. So let's look for the item. Here's the data that an item requires. We know we don't actually need the price because we add prices in later. And we know that we don't need the type because we derived that here from the name. So in fact, this information here is enough to create an item. So let's copy that, go back to our StockAdded, and give ourselves values of those fields. With that knowledge in mind, we can start writing a test. So let's say test fun, and this is going to say StockAdded events create items. So if we had a list of events, and we'll put in a StockAdded event, come back to the bits of that in a minute. Now we should be able to map those events to a list of items. That's items, which is a list of item, is events to items, let's say. Now this doesn't exist, let's create it. So it's going to return a list of item, and instead of working on iterable of t, it's going to work on iterable of stock event. StockAdded would do for now, but we know that we're going to have different types of events. Okay, that's the type of that. Let's fill in some bits here. If we had an ID and a name and a local date for sell by date and a quality, this doesn't compile yet, but let's hold on. then our expected would be a list of, and we had a test item function to create items. So the item would have the ID. In fact, it would have all these parameters. And I seem to have an issue with leading zeros there. Okay, let's remind ourselves, test item here was a factory method in our tests that allowed us to create an item from raw strings rather than these tiny types here that made sure that items could only be given valid data. I think on reflection, a better name for that, I'm going to rename it here, would be item for test, because it returns the same type of item. Let's do that one as well. Now we had the same problem here with StockAdded. It has these tiny types, which are keeping out bad data but a pain in tests. So let's call this StockAdded for test and create that function. Now this is our ID, this is our name, this is our sell by date, and this is our quality. And we know this wants to return a StockAdded event. Take it out of the actual test class into here, and then in fact let's steal that implementation from here. So it will look like that in here, but this is going to be return StockAdded with that ID and so on. Little reformat and make that expression. Okay, back up. Now we can use strict to say expect that items is equal to expected. And now in fact I think we can inline that and that and that. A little bit of reformatting into something like that. Well, that shouldn't be too hard to implement. Go down here and we can say, in here for now, we can just take our events and map them as event to item. That doesn't exist. Let's create that as an extension function, stock event. And this is going to say return item with the ID, the name, sell by date, and the quality. And we're failing because this needs to be StockAdded. We need the whole thing to return item, and this shows that we need to check that our event is the right type. So in here we'll say event to when event is StockAdded, then it's event to item. And then finally I need to return that. Note the compiler knows that the only subtype of stock event is StockAdded, so we don't need another case here for now. Okay, finally let's see whether that passes. We should probably have tried to run it earlier, so we'll run all these tests. And that passes. We should always consider the edge cases, and in this case that's an empty input. So I think we'll just write ourselves a test for that here, and we'll say no events returns no items. Expect that an empty list of stock event to items is equal to an empty list. And because strict has our back, we can actually say is empty. To check that's also true. And it is. I think we probably add to this test to add two items, one with and one without a sell by date. Doesn't change the logic. And we'll make this ID1 and ID2. So we expect out ID1, ID2 with another name null in there. And we do expect that to pass. We'll run it. Good. Okay, so far this isn't very interesting. Let's move on to StockRemoved events. Let's create ourselves one of those. And really, in order to remove an item from stock, all we probably need to know is its ID. So let's say StockRemoved, and the only data we need to capture is the ID of the item. That's caused us here to not compile anymore because now we have another type. So I think we can say here is StockRemoved, and for now that's just a to-do to get this to compile. Going up to our tests, let's take something that's this shape and say StockRemoved events remove items. So now if we had two items like this and then a StockRemoved for test, and we removed say ID2, then we would expect to have ID1 left, but ID2 would have gone. So let's take that out. We don't have one of those. Let's implement it by duplicating this, taking out that, making that stock removed, and removing those. Did I mess up the name? I did. It should be stock removed for test. Oh, and it seems we have a problem with the comma. Okay, we don't have any logic, so we expect that to fail. And we'll prove it by running. It does. Let's just have a look. So we're getting our operation is not implemented. Okay, what should we do? Here's 2 items. At the moment we're using map, and map guarantees we'll be getting the same number of items in our result as we had in our input, but now we know we need 1 less. So we can't be using map. What I will do though is I'll inline that map and see how it's implemented. Well, that's map to array list. Let's inline that. So you can see the way that map is implemented is it creates a destination, and then for every item in its input, it calls add with whatever is returned from our lambda. That's actually quite close to what we want. We can fix this up as mutable list item. And now if we've got a stock removed event, we want to take the item out of our destination, this thing I think we'll call result, rather than add it. So is stock removed, we'll say result remove if, and we want to remove it if the item ID is the event ID. Now confusingly we've named this item, so in fact we want to rename that to be event. Oh, now we have to remove this result add into the case. So it goes in there. Let's see whether that works. Splendid. Now, if you're a functional programmer, you might be thinking we could get clever here. This is a fold, and we could be passing in an immutable list and adding and removing items from that immutable list as we fold over. Personally, I think if mutable lists are good enough for writers of the Kotlin standard library, they're good enough for us. This should be both efficient and quite easy to reason with. But note the mutability doesn't escape from this function. So we're returning this as an immutable list, or technically a read-only list, and that's a perfectly safe thing to do. Starts mutable here, but all we're doing is initializing it in here. Now, what should we do if this item isn't in the list? Roberto's advice in the book is to ignore that, and by extension I suppose that we should ignore the fact that we might be creating 2 items with the same ID. I'm not sure how that will pan out, but I'm happy to take his advice, but let's write a test that shows that behavior. So I'm going to duplicate this one with StockAdded events can create items with the same ID. And so we will basically say we've got ID1 and ID1, and that should lead to ID1 and ID1. So we're not changing the behavior, we're just documenting it. If it passes, which it does. And here we're going to have another test that says stock removed events are ignored if no item exists. So here we'll say we'll remove no such, and if we do, then we should have our ID2 still there. And again, I think that is a behavior that we have implemented. We'll find out by running the tests. Good. Looking at it, I'm a bit suspicious here. We keep on using 42, so we'll just put in a few different numbers in these places and run. Good. So this 2 items is what we call a projection of the events. It's taking the events and interpreting them to yield a list of items. Again, functional programmers would call that a fold. And I think maybe we'll have a look at what it would look like as a fold. If we duplicate this, we could call it interval of stock event fold. And that would then be this dot fold. The thing that we pass into the fold would be an empty list of items. And in the fold, we have an accumulator and an event. The accumulator is our list, and the stock event is every item from this iterable. So now we can take this code here and put it into here, call that event. And now we haven't got a mutable list. This is our accumulator plus our event to item. And by the same token, this is our accumulator dot. Now we want it without the items of the ID, so that's a filter. But we leave in the ones that don't have the same ID. We could remove those, and this is what we return. And in order to test that, what I'm going to do is I'm going to comment out this and implement this with return this dot fault. Have we done it right? Well, we'll find out by running the tests. So there we go. So we can have the mutable version like that, or the functional immutable version like that. Take your pick. Personally, I think I'm going with this one for now. Okay, so here's our current event code in its entirety. We have a stock event, StockAdded, StockRemoved, and this projection of stock events onto items that we're calling toItems. So now what about aging items? Well, to know how to age an item, we're going to have to know two things. One, when was it added to stock? And two, when are we asking? Let's add the first of those, a timestamp to StockAdded. We can go over here and refactor to add, we'll call it timestamp. Its type will be instant. We'll call it timestamp in here, which will help in just a minute. We'll move that up and refactor. And the reason for adding that default value is that this will now be broken. We can add a parameter to this. We'll put at the top and also call timestamp. And if we do that, now these calls are broken, but we can fix them all with a top level field. So we'll call this timestamp. And now we need instant parse something, and today will do. Something in the middle of the day. So that should compile fine and continue to pass the tests. If I just allow the timestamp to pass. Good. And when we don't have a need for a specific value, often I'll call this a timestamp to show that we don't really care. Right, now let's think what a test for degradation might look like. Test, fun. And I think the gist of this is that items are degraded the day after the added event. So what does that look like? I think in this case I'm going to set up a specific timestamp. So we'll say added timestamp is instant parse 2023 02 02 08 T, and we'll get pick midday UTC. Now when we say the day after, we don't mean 24 hours after, we mean when a midnight has passed. And in order to know that, we need a time zone. So I think we need a zoned date time, and we'll parse this as a zoned date time, but we'll look at the next day. So we'll go 09 at midnight. I think we may need seconds in these both. And to prove a point, I think we'll move this to 23, 59, and 59. So in the case of this item, no sooner has it been added than it will be degraded, because it will be the next day. Now if we duplicate this and add with the added timestamp a thing, but nothing else. Now we want to have degraded that. So it will be degraded to 40. Oh, but we'll have to be careful here because it might pass its sell by date. So let's make the sell by date into the future compared to both now and the added timestamp. Delete that. Now obviously this can't pass, but we'll run it just to check. And as expected, we haven't degraded. Now, in order to pass the information we need, we've got to add this now to this toItems. So I'm going to do the same as I did before, which is we're going to go to here and we're going to add a parameter, which is now. Its type we decided was going to be zoned date time. And I'm going to call that now in here. Make that change. And now here we've broken, and I think we can fix that by saying val now is our timestamp, and we're going to convert that to a zoned date time of instant in our London zone ID. And as those are going to represent the same time in all these places here, there will be no degradation. So let's rename that now to be same time as timestamp. If we run that, the tests that we're passing should continue to pass. And do. So we've just got our failing test now, which we might better make work. So now in StockAdded, we'll give ourselves a scope. Now we can pull this out as a variable of item when added. And now we need to age that. Well, items have got an updated by days and on. So how many days is there between the event timestamp and now? That was a calculation that stock had to be doing. So let's have a look. It's loaded last modified days to now with a zone ID. I'll pull that into here. Well, days since added. So that's event timestamp, days to, and now we can go to now and get its instant, and now and get its zone ID. Put that into here, which is irritatingly a long, and the other parameter is a local date. And that again we can get from the zone date time, so that's now to local date. Well, there's a chance that works. Let's run it. Goodness. I'm a bit suspicious when anything with date times works first time. So what I think I'm going to do is I'm going to pull this back to midday, and that should run the same. But I'm also going to say this is day after added timestamp, and I'm going to add a day of added timestamp, which is going to be the end of that day. So that's 08, 23, 59 and 59. And if we use that in here, then we don't expect any degradation. That should be 42. So we've divided this up into the boundary condition. See if that works. And it does. I'm still frankly suspicious that it's working in any time zone other than GMT, but I think we've worked hard enough for today, so we'll take a break there. Okay, here then is our stock event code pulled out into its own file. This seems quite promising as a technique, so I think we'll continue down this route in the next episode. One thing I'm not sure about is this aging strategy. Another way we could do this would be to generate one event per day, which is a stock updated event, to degrade an item. That's interesting because as it is here, if we change our update strategy and reproject our events, then we'll get different item qualities at the end. I don't know what's right and wrong here, but this is an experiment, so I'm going to suspend disbelief and we will see what comes out. And if you'd like to see that, then please subscribe to the channel. I currently have some spare time, so if you're enjoying this content and have a training budget, then please let me know if you'd like to hire me to help you or your team get better at Kotlin. And of course, you could buy the book that I wrote in that price, called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.